Hello all. Today we are going to talk about a new concept called angle of friction. Now we all know that suppose there is a block and we pull it by force F applying externally. So we know that friction will act in this direction to oppose its motion. Okay. Even if the block is stationary, friction is acting in this direction. Then we also know that normal force by the surface, let us put it in red, is acting in this direction, vertically upward direction, right? So now it's important to note that this is called normal force or support force. Okay, not contact force. Contact force will understand what is the contact force. So now if I use parallelogram law vector addition and if I draw a parallel vector to n, let us say this is n, and let us say this is a parallel vector which we are writing it f. Okay, friction, right? Now we can all see that if you follow from here, then two vectors represent adjacent side of triangle. So resultant will be drawn from the tail of the first vector to the head of the last vector, and let us write it to be r. Now this r is called contact force. And the direction at which it acts, okay, let us give this angle to be lambda. This lambda is called angle of friction. So the next question is, what is the magnitude of the force of contact force, right? Now if you pay attention to this triangle, right angle triangle, then r is the hypotenuse, right? So from the triangle we can write r to be equal to root over f square plus n square. So this is the magnitude of the contact force. So magnitude of the contact force is root of friction plus n, right? Now what is the direction of contact force relative to n? So that is called angle of friction, right? So again, if you use tan alpha here to find the direction of r, so tan alpha is perpendicular, which is f by n, and f value is mu times n by n. So we are going to get a relation like mu equal to tan alpha. So this is the direction, or direction you can say that is lambda equal to tan inverse mu, right? This is the direction. Now let us have one more look how we define it. So now you can say that contact force horizontal component is called friction, and contact force perpendicular component is called normal force uh, or support force. Okay, let us say once component of r along horizontal is called friction. Okay, so what is friction? Component of contact force along horizontal. Okay, component of R along horizontal. This is the definition of friction force. And component of R along vertical, okay, is called normal force. And if you pay attention, the angle of friction is defined to be angle between R and end. Okay. Now, so this is all about contact force and normal force and support force, friction. Okay, these three are related. Now you should understand that there is something called contact force which acts like this. One component is friction and one component is normal force. Okay. Now, whatever I have said for this body, you know that this body will apply friction in this direction, right? Now, so same thing is true for this surface also, right? This surface also feels so for this surface just it will be the symmetry force will be in this direction, right? Friction on this surface by this block, of course contact force will be in this direction and so on. Fine, same thing applies for this second surface also. Thank you, and I will see you in my next class.